Welcome back to part 2 of Unity Basics. Let's just go right into what we were doing last. So basically, these objects fall because we have a physics component on it, and if you haven't seen the last video, I recommend you watch it first if you're trying to get into Unity and you need to know the basics and get some good fundamentals down. So, using the Rigidbody 2D component and a box collider, we were able to make this object affected by gravity, and we're going to go through the rest of the properties. So, auto mass, I believe, sets the mass based on the amount of matter it takes up. So based on the size of it, it will adjust its mass, which is actually really cool. If you want to make a game that's physics based and you have different sized objects, just do auto mass and it will act as if everything is the same material density, and it just based on size adjusts your mass. So that's cool. But mass isn't going to affect the speed of gravity. It is going to affect how it hits other objects. Linear drag, I believe, is the friction in the air, kind of like a wind resistance. It's mainly used for top-down games where there isn't gravity, because you can't have friction otherwise without it. Angular drag is the air friction, I guess you can call it, or air resistance, but the effect it has on the angle at which your thing turns. And it's usually a low value for most games I've worked with. Gravity scale is cool. So it's a scale, so it's times the normal standard gravity, which is 9.8 meters per second. So at 1, it's 9.8 meters per second. Then at 2, it is double that. So when we press play, it will fall really fast, like so. And it's pretty cool for platformers if you want to make it a fast-paced game. That's really nice. And I guess I'll throw this in too. While you're testing your game, you can actually go to the scene mode and drag around any object within the game, and will actually live update it. So you can make adjustments during your playthrough and during your debug sessions. That's kind of cool. Also, any properties you change within it will go back to normal when you're done. So if I make this object white for now, when I unplay it, it will go back to black and the size goes back to normal as if nothing happened. So you can mess around with different settings and just try stuff you wouldn't want to do to your project normally and see how it works in game. And just when you press unplay, it's done. It's gone. That's cool. Is kinematic is when an object isn't updated until it's touched by another physics object. That's commonly used, like say you had a bowling game and you didn't want to calculate the physics of the pins until they're actually hit with another pin or a ball. You would make them kinematic. Interpolate, I actually don't really use this. I'm not sure what it does. If you're interested, you can look more into it, but it hasn't been important for me in my experience of developing. Sleeping mode is when the object isn't actually being used. It's much like, I guess it's like kinematic in a way, where if you start asleep, the object shouldn't move until it's awoken. And I'm sure, you can call that through code if you want to wake an object, but that's what that is. So collision detection, discrete and continuous. Based on the sound of it, it's how often it checks for collision. So an object that's not going to be collided with a lot, you can make discrete. An object like a bullet that needs to continuously check, like very important to see if it hits someone, you don't want bullets clipping through other players, you would make that continuous. And then finally we have our constraints, which are pretty cool. So constraints, we can freeze the rotation of an object, which is extremely useful. So now when this object falls, it's just solid, and that's that. Like, that angle is all it can rotate to. It can't rotate to anything else. Any other angle you choose, it just won't be affected. It can't rotate. And if we lock position X, when we drop it, it's always going to be within this this same area, even if we rotate it, because now it can rotate actually. But it really can't because it's locked into X. It can only fall down X. Like if I put that, we lost it. If I put this right over here, should get a good example. See how it rotates, but it just kind of stays in the same X. That's what that does. And then Y does the same thing for Y, but I can't really give you an example for that because it's not going to fall. So there you go, froze Y. However, it can move left and right. Just not really a good way to show you that. I guess that works if I put it there. Kind of pushes out, but only to the right. So those are your constraints, and that's all the properties for Rigidbody 2D. Of course, there are so many more things you can look into with Unity. such as different types of collider, polygon colliders, edge colliders, different joints you could use, all sorts of things. But this is just the basics, and I think physics are a pretty basic thing with Unity. So we're going to go ahead, make those settings the same as they are, and just add a physics 2D to this object right here. And we're going to give it not a box collider, because as you can see, the green line doesn't really fit around the triangle. We're going to give it a polygon collider, which will adjust based on the shape. So we can put a polygon collider, and now it's actually with the texture. But let's say that that wasn't the shape you wanted. Let's say that you wanted it to just like dig in at some parts. For some reason you want it to be concave. You can press edit collider down here, and now you can actually create new joints within the collision, and you can make it however you want it to be. So if you wanted it to only collide like that, and these parts are see-through or don't actually have any physics to them, you can do whatever shape you want and adjust it however you need it. So to make a new one, you just click on any sort of line segment and it will create a new one. And to delete one, you have to hover over any joint and press the delete key, and that will delete the joints. That's how you make different polygon colliders. So we'll get into physics materials too, I guess, since we're here. So when we press play, there's two physics objects, and they're going to interact if they actually hit each other. Make them hit each other. So it falls down, the triangle bounces off it. Cool. We're going to add a physics material. So we can right click down here, go to create, and now we can choose physics 2D material, which is down here. We're going to call it rectangle. Okay. So now we have two different properties, friction and bounciness. Bounciness is, as you see when you fall, you don't really get any sort of bounce to it. It's basically the coefficient to how much it bounces. So if you make it 1, it should reciprocate the falling speed for the most part, if we actually added it to something. So 1, it would reciprocate the falling speed. 0, there's no reciprocation or bounce. 0.5, if you fall and hit the ground at 10 meters per second, you bounce at 5 meters per second. That's what I'm trying to say. It's like, it's the coefficient to however much you bounce based on how hard you hit something. So we can add friction too. If we want to make it 0 friction, objects will just slide on. Make it higher friction, then they will stop faster and they won't move as much or slide on objects. So we'll leave the friction at standard, and we'll make the bounciness 0.5. And we're going to only apply it to this object. So there's two ways to do that. You can either drag it onto an object, and you get that little plus with the box. You can let go, and now you have it on the object. Or you can do it this way, where you drag it onto here. Or I guess there's a third way, because you can click on this little dot here and then choose it from your assets or your scene. So now when we play, we're going to have an object actually bouncing around now. It's pretty funny to look at. So it bounces, kind of spazzes out, hits the other object that doesn't have these properties, and notice how the other object also doesn't bounce, right? Two different physics properties. You can do that with anything. Have as many physics properties as you want for whatever you want. We can even apply the rectangle one to the triangle and make them both bouncy if we want to. There you go. So that's the basics of physics in this. I mean, there's a lot more you can do with it, trust me, with actual programming, but I'm not going to get into programming in this. This is really just getting to know the editor and getting to know Unity. And even going into a few of these component things might be a little bit too advanced, but it's just important to know this stuff. So I guess the last thing I'll cover in this basics tutorial would be the main camera. So let's talk about that a little bit. If we look at our main camera and we're selected on the normal 2D editing tool, you'll have these little like box joints here that you can adjust. So when you pull it up and down, that adjusts the scale of your camera, like so. And if we look at our camera preview down there, we'll see that the preview changes. It's not that the objects are getting smaller, it's just that we're rendering them from a farther distance or from a wider range. If we go to our game view, they look a lot smaller, and we can make them even smaller depending on how big our camera is. What's cool about this is that you can edit this in-game. So you can have cameras that are flexible and zoom out to show like a whole level and zoom into your character. All sorts of things like that. Any property, any one of these properties, anywhere can be edited from within the game. And that's why like Unity is so easy to work with, because it's just so easy to edit stuff and make things your own. So the viewport, I guess we'll start with the background color we already went over. The skybox you don't really want to change for a 2D game. And projection you want to keep orthographic for a 2D game. The size is what we just kind of looked at. You can just adjust it from here. Clipping planes, that's not really important either. Viewport is weird. So because you can have multiple cameras in Unity, your viewport is where the camera actually shows in your game preview. If I could show you what I mean. So this is your full game preview, right? We can make it kind of like a mini map. You can have different cameras throughout the screen. So if I made a second camera, I can have like a little mini map up here by adjusting the viewport. So that's just the size of the camera in comparison to how much of the screen it takes up, and then where you want it. It's a ratio out of 1. So the width and height are 1, so it takes up the entire screen. And now the X and Y are 0, so it starts at the top left corner. You can adjust that however you want. If you want to make like 2 cameras, like mini map type thing, in the top left corner, that's how you would do that. The rendering path, you don't need to edit any of this stuff. Pretty straightforward. And occlusion culling, I think is how it's pronounced. That's just it unrenders any object that's not on the screen. It's standard in most games now to make things run fast. Like you probably played Gary's mod before and you faced a bunch of stuff going on and you lag really bad, and when you look away from it, you just stop lagging. That's what that is basically. And these are all just standard things on your camera. So that's the basics of Unity, really. There's not much more about the editor I could show you for now. I guess I could show you tagging and disabling, but that's pretty straightforward. Much like the layers, you can choose tags and like add new tags. And then you can disable an object. So if I don't want to use this object, but I don't want to delete it, I can click on that, and now it's just temporarily gone. So when I play the game, it'll just fall as if nothing's there. Alright, so I'll end the tutorial here. Thanks for watching. I hope you learned some basics about Unity. Check out some other tutorials for learning how to make different types of games or learning how to program in C#. For people in my club that are watching this, I'll probably make it a thing you have to watch before coming on the first day. So just check out some more tutorials, get a good idea of what you want to do, get a good idea of how to use Unity, because knowing how to use the program makes it so much easier to actually create with it. Honestly, like once you know what to do and everything's second nature to you, you'll make stuff so much faster and you'll have so many more possibilities to create. So that's all I have to say. Once again, thanks for watching, and check out some more tutorials.